Welcome. Welcome to another episode of Mr. McEwen's video tutorials.
Okay, how are you doing? Today I'm just going to do another example of claim evidence reasoning, which we've been doing in class for about 2 weeks. It's very important that you can do this for any type of question that either I give you or that is given or that you come up with and we do an investigation or an activity with. So I'm just going to look at investigation 3. So this is one we've done in class. It's in your science notebook, but here's exactly what I've been trying to accomplish with this in class. So the question was, do all planets move in stable orbits around stars? That's the question. It's what you're being asked. There are answers to that. You can make an answer to it, and your answer is actually your claim. It's what you think. You don't have to go into details about why you think that or what evidence that you might have. You just need to answer the question. So you can answer this in 2 ways. You can say, yes, all planets move in stable orbits around stars, or you could say, no, not all planets move in stable orbits around stars. The word all is such a big word that there's really only 2 answers to this. So I'm going to answer the questions. No, all planets do not move in stable orbits around stars. Boom. Boom, that's it. Beep, beep, pop, pop. That's it. So we've done that. We've figured out what our claim is. That's what I think. I'm going to try to prove that using the evidence from our computer model that we ran, where we were trying the different velocities in the y direction. We ran this. This is the data that, this is the data that I kind of collected and have been messing around with. You can see there's the run, which is the number of the simulation that was run. We did 9 of them. We put in the VY2, which is for the first planet, or body number 2, and then the result of what happened with that orbit. And then VY3, which is the second planet, or the third body. Remember, the sun is the first body. So in this way, we can either talk about planet 1, 2, and 3, or we can talk about body 2, 3, and 4, whether or not we're talking about the sun in this. So this is one set of data from one run where we chose these 3 values for the velocity in the y direction, and this is what happened to those 3 planets, or the body 2, body 3, and body 4. I'm not going to go into data collection, but we used words like collide. We talked about with what. We used words to help us explain our observations. So now we're going to use those in our evidence section. The evidence is going to be the information from our observation, our data, and our numbers that are going to help us prove that no, not all planets move in stable orbits around stars. Now I have 9 different runs from our computer simulation to choose from. So I'm not going to use them all. I want to pick out ones that show that the different things that can happen. So I've already highlighted 4 that I thought were important. You could prove this with 1. You could prove it with 2. You could prove it with 3. The depth, or your how well you describe it, is important as well. So I think 3 is a minimum to do a really good job. I picked out 4 that were all different. I've got one that here is stable. I've got one that had 1 stable. I've got one with 2 stable. And then I got one here that has some kind of strange things happen. So I picked some ones that I thought were interesting. If I had drawn the pictures in here, it would have helped me kind of get an idea of what happened to that at the end. But I didn't put the pictures in here. I didn't do any sketching. So I'm just going to say, I'm going to list my evidence here right now, and I'm not going to talk about why I chose it. I'm just going to tell what happened in my observations. So if I look, let's see if I can move that over. So the first one is, let me see that. Oh, that's much better. I'm just going to tell in run number 3. when I chose values or numbers for v, y, for the 3 planets, and I can decide, I can talk about, I can do this in many different ways. I might just this time say, show the 3 values for the 3 planets. And that's planet 1, planet 2, planet 3, or body 2, body 3, body 4. I'll show you some other examples in the next evidence of another way to do it. But this way I'm just going to show this. I'm pretty obvious. The body number 2 collided with the sun. Body number 3 had a stable orbit, and body number 4, and I can actually look at this. Copy. Let me see. Can I just copy and paste? Nope. I can't. I have to. Let's see if I can do that. Copy. Paste. Had an unstable orbit until body 2 collided with the sun, and then it became stable. Okay. That didn't work so much. I kind of need to say it in my own words when I move it over. So that's one piece of evidence. Do I talk about why that supports my claim? I mean, it's pretty obvious that all the bodies in this run were not stable. Okay, so but I need to put that over here when I talk about my reasoning. This run shows that only one planet had a stable orbit for these values or numbers. This supports, I mean, I could just say this supports my claim that all planets do not move in stable orbits around planets. And I'm going to be saying that a lot because my evidence should point to the fact that not all planets move in stable orbits. So I'm going to do this a little bit quicker. I look back down here. I've got this one right here, number 6. So I'm just going to right here in run number 6, the values for, and I'll show you another way that you can write the same information. The value, I should say, I set the Vy for planet 1 at, let's see, 100, and it had a large stable circular orbit. Planet 2 I set to 100, and it had a medium stable orbit. And planet 3, I should really I set to 100. Oh, you know what? I should have just said. When I set the Vy to all 3 planets at 100, that would have made more sense. It had a small circular orbit. In this case, the planets did have a all of the planets had stable orbits. Okay. Maybe I should have, you know what, and I think about, this is good. So I'm just going to say in run, And then this, I'm going to go back to the other way of doing it because it's a little bit quicker. So in run number 8, I set the values to, let's see, 120. And I'm looking over here, I'm looking at my run number 8, 120, 120, 120. So 120, 120, 120. And body 2, I'll go back to calling them bodies. I should, if I'm going to say bodies, then I should stay with bodies through all of these, like up here. Okay? If I'm going to use planets, I should use the planet through all the evidence. I'm giving you examples of different ways that you can do this. But I would stay with the same format. If you're going to call them bodies, man, then keep it as bodies. So I'm just giving you different formats. Body 2 and body 2. Let's see what happened. It's had a wild orbit. Had a right before leaving the system. Body 3 had a stable orbit. And body 3 had a wild orbit. I'm just going to copy this and paste. I just put in had a wild orbit that crossed paths with body 2 and then crashed into body 2. This supports my claim that all planets do not have stable orbits. Okay, and I would go on to say, let me put one in more, in run number 9 with values for Vy at 20, 40, and 60. There, body 2, body 2 had a stable orbit. And we should say small stable orbit because that's what it says right here. Small stable orbit. And body, let's see over here, body 2 had a large stable orbit. And body 4 collided with the sun. Okay, I need to make sure that I get out of this. Body 3. So I need to go back and do a little bit of editing there, making sure that I'm putting good information in. Okay, I think that's just a space there. Here is another example of how the orbits can change. Okay, so now I've got, look at this. This is a lot of evidence. I'm looking at this one. This really doesn't prove my but I think what I like about this one is that you're saying this one where we did get stable orbits going around the entire all 3 planets had stable orbits. You really could look back at your claim and say, well, some planets move in stable orbits around stars. That has to be true because our planet's moving in a stable orbit. But, you know, by saying no, all planets do not, you're saying that there are some that do, there's some that don't, there's some that crash, there's some that exit the system or leave orbit. So I've given lots of examples of things about what they've done. what some of the things can happen to. So I think I've clearly supported my claim using these 4. Now, and I don't want to go into this now, but in order for me to write my scientific explanation, I can use my claim, and then I just start using my evidence. Now, and this is basically how we're building our scientific explanation. Since all of these showed lots of examples, let me back up. Well, you know what? I'm going to say that I'm just going to say a conclusion to this. These are all examples of many different types of orbits or outcomes for planets in a system. I could have really copied this part, and then after it show that this is what this run shows. This one shows. But I'm just going to kind of summarize all this at the end in the system. Planets. Oops. Oh, planets. Planets can have stable orbits, unstable orbits, cross paths, exit this system, leave orbit. I mean, I can talk about leave orbit, collide or crash with other objects. And did I make sure I said it? I'll just say that. And or just say or collide or crash with other objects in a system. You see? This evidence supports my claim. Then basically, that's what we're working towards, is building a scientific explanation. So this is a long video. I'll just let it go at that. Thank you very much.